This is Euclid Book 11, Proposition number 4. And this is a dandy and a peach to draw. I can assure you of that. So what does it actually say? It says, if a straight line be set up at right angles to two straight lines which cut one another at their common point of section, it will also be at right angles to the plane through them. Okay, how do we draw this? For let a straight line EF. What is EF? Well, I'm going to show you what EF actually is. This line here is EF right here. We have to draw that. Now that is not as easy as you think to draw. Let me explain. For let a straight line EF, which we've now shown you, be set up at right angles to the two straight lines AB and CD. Now what are the two straight lines AB and CD? Well, here's AB right here. See that one? And here's CD right here. Here is my suggestion if you're going to do this the correct way. You're going to use Euclid Book 1, Proposition number 11. And what you're going to do is you're going to draw the perpendicular to this line here. Then you're going to draw the perpendicular to this line here. And then you're going to draw an arc between those 2 points. And wherever the middle of that arc is, that's going to be point F. And then you're going to draw your EF like that. It's the only way I can think of to draw this as closely to what this is supposed to be. You get the idea. Basically speaking, if you look at the drawing real carefully, you can see this, it's not exactly 90 degrees, but it is very, very close. And this one is definitely 90 degrees. I can tell you that right now. So this one cut this one at 90-degree angles. This one not quite so much, but it was so dang close that it wasn't such a big deal. Okay, but if you draw it a little more carefully, that's exactly how it's going to come out. Okay. Now that we got that hard part out of the way, and that's the only hard part of the whole thing. Okay, now all this has to be contained in this parallelogram. See this parallelogram that goes from here to here to here to here? Okay, all this has to be contained inside of it. You'll find out why in just a minute. Okay. For let a straight line EF, which we just showed you, be set up at right angles to the two straight lines AB and CD, which we showed you, which cut one another at point E from E. Okay, there's point E right there. I say that EF is also at right angles to the plane through AB and CD. So what that means is that AB and CD lie parallel to this plane right here. They're literally on top of it. They're not floating above it. They're not floating below it. They're right on top of it. Okay. For let AE, EB, CE, ED be cut off equal to one another. Okay. So this length is going to be equal to this length, and this length is going to be equal to this length, and they're going to be equal to one another. Now what I did was I drew two 4-inch lines, so this is going to be 2 inches, so is this, so is this, so is that. Okay. And let any straight line GEH be drawn across through E at random. So we drew GEH like that. Okay. Let AD and CB be joined. Okay. AD and CB are now joined. And further, let FA, FG, FD, FC, FH, and FB be joined from point F taken at random on EF. So, I'm going to join this, 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 and this. Join them all. Now, since the two straight lines AE and ED are equal to the two straight lines CE and EB, and they contain equal angles by Euclid Book 1, Proposition number 15, Now, let's stop right there. So, since the two lines AE and ED, well, what's the two lines AE and ED? Well, that's AE and that's ED. Okay? And these two lines are equal in length to CE and EB. CE and EB. These two lines here are equal in length to these two lines here. And they contain equal angles by Euclid Book 1, proposition number 15. Therefore, the base AD, which is this, is equal to the base CB, which is this. And the triangle AED, which is this, AED, this triangle right here, will be equal to triangle CEB. CEB. And why is that? Because of Euclid Book 1, proposition number 4. So the angle DAE, well, that's D, and that's A, and that's E, that would be this angle right here, is also equal to the angle EBC. EBC. So this angle right here is equal to that angle right there. But the angle AEG, which is AEG, that would be this angle right here, is also equal to the angle BEH. BEH. So it's equal to this. These two are equal. These two angles right here are equal. AEG and BEH. And this is by Euclid Book 1, proposition number 15. Therefore, AGE, here we got AGE, okay? Now I think I made a mistake a minute ago. Let me say this again. But the angle AEG, which is this one right here, I guess I could just illustrate it. This one right here is equal to BEH, which is this one right here. Therefore, AGE, that would be this one right here, okay? Well, not even the angle, that whole triangle, this whole triangle, AGE, right here, this one right here, this whole triangle, and BEH, this is BEH right here, this whole triangle right here, okay? These two triangles right here are two triangles which have two angles equal to two angles respectively, and one side equal to one side, namely that adjacent to the equal angles, that is to say AE to EB. So this line right here is equal to this line right here. Okay. Therefore, they will also have the remaining sides equal to the remaining sides, and that's by Euclid Book 1, proposition number 26. Therefore, the line GE, I know this is getting a little complicated here, is equal to EH. This line right here is the same size as this line right here. And AG to BH. Okay, what's AG? That's that line right there, and that's that line right there. Those two lines right there and there are equal in size. And since AE is equal to EB, since this line here is equal to that line right there, while FE is common and at right angles, okay, therefore the base FA is equal to the base FB. So, FA right here is equal to this line right here. These two lines right here are equal. And the two sides FA and AD, so we got FA and AD right there, are equal to the two sides FB and BC respectively. So FA is equal to FB, FA is equal to FB, and AD is equal to BC, AD is equal to BC, And the base FD was proven to be equal to the base FC. So now we got base FD, this one right here, and this one right here. So this line right here is equal to this line right here. I know it doesn't look like that, but it is. Therefore, the angle FAD right there, is also equal to the angle FBC. So, FBC. So, alright, FAD, that would be this angle right there. From F to A to D, that angle right there is equal to FBC, which is this one here. Getting this so far? Good. And this is by Euclid Book 1, proposition number 8. And since again AG, okay, was proved to be equal to BH. Well, this is AG, and it's equal to BH. And further, FA is equal to FB. This line right here is equal to this line right here. Whew. The two sides FA and AG are equal to the two sides FB and BH. So FA is equal to FB, AG is equal to BH, and the angle GAF, okay, what is angle GAF? Well, that's this one right here, was proved to be equal to the angle FBH, which was this one right here. Therefore, the base FG is equal to the base FH. Okay? FG is equal to FH. Now, since again GE was proved equal to EH, okay, GE, which is this one, and EH, which is this one, and EF is the common, which is this one. The two sides, okay, GE is equal to EH, EF is equal to EF, and the base FG is equal to the base FH. FG, which is this one right here, from F to G, is equal to F to H, which is this one right here. Therefore, the angle GEF, which is from here to here to here, which would be this, I'll try to draw that one there, okay, is equal to HEF. What is HEF? That would be this one right here. Okay. And that's by Euclid Book 1, proposition number 8. Therefore, the angles GEF, which is that great big line I showed you, and HEF, both of those angles are right. Therefore, EF is at right angles to GH, drawn at random through E. Okay? So, what we're saying here is that EF has been drawn to right angles to GH right there. Similarly, we can prove that EF will also make right angles with all the straight lines which meet it and are in the same place of reference. But a straight line is at right angles to a plane when it makes right angles with all the straight lines which meet it and are in the same plane, and this is by Euclid Book 11, definition number 3. Therefore, EF is at right angles to the plane of reference. But the plane of reference is a plane through the straight lines AB and CD. Therefore, EF is at right angles to the plane through AB and CD, etc., etc., etc. Are we dizzy or ditzy yet? I know I'm getting close. Well, I wanted to thank you very much for watching this presentation. I first drew this in pencil, and then I covered it over with ink pen so you could see it a little bit better. That's all I did. Okay. Well, that concludes Euclid Book 11, Proposition number 4. And I guarantee you that Euclid Book 11, Proposition number 5 is no more fun than this. But anyway, now you pretty much know how to draw a perpendicular to two straight lines. Well, at least as best as you'll ever get. Anyway, I want to thank you very much for watching this presentation. I will tell you more in a future video, so I want you to stay tuned.